Hello, everybody. We're talking about Wasmer-JS today and how it works. So this is Wasmer-JS, Wasm-Mario, Wasmer-JS, and here's the repo. What it is, it's a JavaScript project organized by Lerna. Lerna manages multiple packages all in one place. That way you can like deploy them all together and does all kinds of fun things. Like if you run Lerna run build, it'll build all the packages in parallel and things like that, or it'll even figure out what's depending on what package and make sure it builds the dependent packages first before it builds the parent package. There's a bunch of stuff like that. But yeah, so we have it like a monorepo style. We have contributing docs for everything, and we have a nice quick start, which someone already contributed to, which is really nice, and a quick intro on using Lerna. So the first package you probably want to take a look at is Wasm-WASI. This is just our simple, it's not really simple, but it is our library for pretty much taking in a WASI file and then mocking out all the imports in the system calls it's going to make. That way we can mock them out in JavaScript, and then it keeps running the way it should. We have a README. Looks really nice. It's a project based off of Node WASI, but also updated to match the current node of what Node's going to do with WASI. So it matches that API rather than their API, but it uses Node WASI in the background to do all of its mocking and stuff. So we make it really easy to plug in different file systems, whether it be Node.fs or our own Wasm.fs, which is using memfs, but we'll get into that a little bit. It's all written in TypeScript, and it's all JavaScript, and it's about 15 kilobytes, which is really nice if you care about web performance. So you have installation docs. And
the 15 kilobytes is already gzipped?
Yeah, that's minified and gzipped. So if you were to download it off and put it in production, it would be about 15 kilobytes, which is for what we're doing not that bad.
Nice.
So then we have a quick start. Pretty much this is like the API on how to use it. You initialize a WASI thing. You also include a Wasm.fs, and then you could use an async thing or an async task, and you just fetch the Wasm module, stuff like that. It's just standard stuff. I mean, I'm not going to read this entire example to you, but check it out. And then we also have reference API docs, which I think are still up to date, so we'll have to look into that. But yeah, in general, we had some challenges with this. So we have a lot of polyfills that needed for the browsers, such as HR time. This is really needed for a lot of clock time get and other WASI imports and things. And then we also have polyfills for data views and Bigin. Bigin's probably the biggest one that's most notable because you can't call into WASI because WebAssembly allows 64-bit integers. JavaScript doesn't have that until Bigin came around, which is very new. So you can't call between the two using 64-bit integers. So we had to mock it out with a polyfill, where essentially just brings back a 32 where it needs to and stuff like that, which gives you less accuracy, but we've noticed it working for 99% of the cases, which is really nice. And then what else do we have? We have different bindings. So this is isomorphic. It works both in the browser and Node. So the browser has a lot of the polyfills built in. That's where we're mostly using them. But also file system needs to be manually attached, whereas in the Node bindings, it goes ahead and uses Node's native FS and as well as path and stuff. There's less polyfills being used compared to the browser. And yeah, I think that's a pretty good overview of WASI, what it's doing. If you take a look at Node WASI, or you take a look at this, you can see it's mostly listed from Node WASI with some small changes and typings added. But other than that, that's pretty much what it is. Let's go back to what other packages we have. So then we have Wasm.fs. This is something that we're currently working on. It's going to provide the file system for our implementation. It's, as of right now, just more of a sandbox Node.fs implementation. That way it works with general file read and stuff like that with the WASI imports. And uses memfs, which pretty much provides our FS API integration. And right now it will scaffold some of the common files, such as standard input and output. That way we can just pretty much do terminal type things. And you can also override things manually. That way we have custom handlers for our standard input when we get into the Wasum Terminal and things like that. But yeah, also have a simple API on how to get started with it. And we have reference API docs here. The implementation is super simple, but we currently have a PR in to actually add support for things like ls and cat in the browser that pretty much we're forking memfs to fix some bugs, but also add more features that we need. So this package we may not need it in the near future. Cyrus doesn't think we do, but I think we might for things like frame buffer and stuff where we're doing more Wasm specific APIs and things. But that's a discussion to be had later. But yeah, just know that this might change dramatically or be removed.
Actually, I have a comment on that. Have you considered making a persistent file system using local storage?
Yeah, so that's one thing we've actually have considered. Instead of using local storage has a limit of 2 megabytes, or the thing you'd want to use is IndexedDB, which allows up to 2 gigabytes, and honestly, as much as you want. But yeah, so right now there's another, I'll get into it later, but yeah, TLDR, yes, we can totally do that. It's in our plans. So then what other packages do we have? Then it would be the Wasm transformer. So this is actually just the output of a crate. So we have also some Wasm crates, and this is Wasm transformer. What it does is that it can run transformations on WebAssembly binaries, and we're mostly using this just for one feature, and that is going to be lowering the I64 imports. So as we said earlier, passing big-ints between WebAssembly and JavaScript doesn't work, and WASI has some imports that require big-ints. So what this will do is inject trampoline functions into the raw WebAssembly binary bytes by using Wasm parser to read through the WebAssembly binary. And then once you find out where everything's located, you can start injecting trampoline functions depending on like what the signatures are and stuff. This is like, it's really fast because it just does one pass straight through, just reads and marks points in the binary, and then we go back and inject stuff into it. Emscripten and Binarium, they both have support for doing the same feature, but what they'll do is they'll go create an entire abstract syntax tree, then you do the modifications, and then it recompiles back from the abstract syntax tree. And we wanted to run this on the client just so we can get it going faster in our larger WebAssembly.sh project. This is something that we could do on the server, but then we have to also store all the different transformations or permutations of transformations of everything uploaded to Wapom. We wanted to also support locally uploaded files, which is why we chose to do this on the client and why we need to do it on the client. And yeah, pretty much some of the design decisions on why we didn't use some scripting and things like that. But going into how this works, if you look at the source code, essentially we have lib, which is just like the general outputted API for using this in both Rust and in the browser. We're using Wasm Pack, so we have a WebAssembly compiled version of this, which is what we get the Wasm transformer output from inside the packages. And then we have transformer, which is pretty much the actual thing that does the logic of that. And it's pretty much divided into 4 steps. Just don't quote me on the number, but it's divided into steps. Where first we're going to go ahead and parse the WebAssembly binary. Then we go ahead and generate the things we want to throw into it. And then we actually apply those transformations. So pretty much it's like parse, generate, apply. Those are the 3 steps. And each of those have their own intricacies that I probably won't get into here, but feel free to look through the source code and that'll show you what's going on. And then, so we have one last package in Wasmer.js, and that is the actual Wasum Terminal. And that is pretty much the end goal of what all these packages come together to build. And it's a terminal-like component for the browser. So you just pass in a container object, and then it'll bind an actual terminal that you can type into and do all kinds of stuff. Its main 2 dependencies are xterm.js, which gives us that terminal UI, and comlink, which allows us to do a lot of web workers and dividing up each, I guess, Wasm module or process into its own web worker that then gets run and they talk to each other and things like that.
So
it uses the other packages.
Why we need web workers?
We need web workers for 2 distinct reasons. The first being that way we can have, well, I guess a couple more than 2 reasons. One being we wanted things to run in web workers, that way they can run faster and in parallel. 2, so that way they can actually pipe between each other and pass data between one another while they're both running at the same time, the same way a Unix system would. A third reason is if a program infinitely loops, since JavaScript, it runs single-threaded, in the context of like the browser, single-threaded is a vague term. JavaScript runs single-threaded with air quotes around it. So if you run an infinite loop WASI module, then it'll just lock up your browser because you can't run it. And then another reason for web workers is kind of not really, but since we have standard and read and that's synchronous, we want to have web workers, that way we can kind of pause on the read, and then that way we can do stuff on the main thread and then pass back the data that we need for the read, and then we can continue it after later, and that's using like atomics.wait and things like that. So the 2 main reasons are for atomics, shared array buffer stuff, and also infinite looping modules is why we need web workers, and they kind of are in conflict with each other. But yeah, does that answer your question? I'm gonna keep going.
Yeah. Yes.
Okay, cool. So that's why we need web workers, and also just web workers are cool. You should be using web workers. It's also good practice on the web. So yep, this pretty much allows you to pass your own custom Wasm binaries, and also uses Wapum for fetching commands. So if you type calsayo or whatever, it'll go ahead and go to Wapum and then download calsay from there and then start running it. Here's a quick start, pretty much. It's using a callback-based API. So pretty much we have different callbacks like fetch command, where you pass in a function, and then you have complete control of what happens in that function. And all we pass you is the name that needs to be fetched of the command. I think Cyrus made some changes so that this can now take in args and standard in to make that decision as well. But we'll get into that. That's something that's coming in the future. And then it also exposes some of the underlying Xterm functions like fit and focus and blur and things. Another thing that's kind of funny about this is that it has its own CSS. We need to import Xterm CSS, and users need to know to do that. And we also tell them that they need to provide, so the Wasm transformer, it's here in the docs, like, hey, you need to use the Wasm transformer if you want most things to work. Since they have control over the fetch command, this is something that's a documentation issue, but not really built into it. And then another thing they need to pass in is the worker for the processes, so the web workers that Comweekly uses. And the reason why we're having them pass in URLs and like managing it that themselves is because if we were to embed it through base64 and line it, the entire bundle size would grow by at least 30%. And that means time to first paint things would be extremely slower. And we don't want to force users into doing that, which is why we think for developer ergonomics, it would make sense to have it a version where it's already inline. That way for development and things, you're not just like having to figure out, well, the URLs aren't resolving the right way. You can get up and running faster. But for production usage, we definitely want people, at least I definitely want people to not be forced into inlining these larger files to lower their performance on their websites. I guess bloating their websites especially. So everything is very progressive where like, we just want to paint as fast as possible. And then as they run commands, we start to then download more things as we need them. And yeah. So going into it, let's see how the code is actually laid out. It's mostly laid out into the concept of terminal, which is the UI, which is this. Pretty much that's what Xterm is and things like that. They talk, then it talks to a TTY, which is pretty much what handles all the text between the TTY, the terminal, and the shell, which is the actual like logic of going ahead and running the commands and things like that. So like taking an input, parsing the command, and then running the command runner, we call it, which is a service that will take the WASI file and create the WASI command and all that. So as a good example, this will handle prompting. So you call, the shell will prompt, and then it'll use a TTY to read something from that's being input from text. And then also can like say, hey, give me the input. And let me see, like Wasm TTY.print. Like, that becomes the text layer, or that becomes the layer between the terminal and the shell where they talk to each other and output things to the terminal. So things like that. And then we have a few services I want to get into inside the shell that the shell uses. And that's going to be over here in, lib. And then command runner is one of them. Command runner is the one that pretty much you pass it a command. So like a string, it'll go ahead and parse it and then get all the command options and then go ahead and start running them. So try to spawn process, and what that's going to do is create a web worker and things like that. And that'll go ahead and run the actual WASI command that it got with all of its args. And then whenever it's done, it'll spawn the next process and so on and so forth, depending on you using piping. And then we have the process, and that is the actual like thing that gets run inside the web worker. And we did a nice thing here where in our actual build system, that's one thing I forgot to go over the build system. In our build system, we have it so that it'll go ahead and just build the process by itself as a web worker. So that way, pretty much it outputs a process.worker that then we can use. But also in the case of where we don't have web workers, we just go ahead and build it in as well to the main library. So process is available both inside the web worker, but also outside of it, depending on if we support web workers or not. And then I think that's it for it. The other last thing, I guess, is fetch command from Wapum. As we mentioned, we had a function API, and this pretty much is an easy way for users to just like get Wapum support for their Wasum terminal without having to figure it out themselves. And that's about it. One thing I forgot to go over was build system. All of the different libraries use Rollup. The reason why we're using Rollup has historically been better for libraries, and then apps became later, whereas Webpack has historically been really good for building apps, where Webpack abstracts a lot more, whereas Rollup gives you a little bit more fine-grained control. of what's going on into your bundle and things, which is kind of what you want when you're building a lib. That way you can do browser differences and stuff, handle that a lot easier. And also there's a bunch of plugins that you can then easily transpose. Whereas Webpack, you get into the Webpack config and like you kind of are in a black box where it's just like, I want to add a plugin, and then you don't really know what that plugin does or how it handles things really well, I would argue, at least. But definitely historically, rollup has been better for libraries. So every package has a similar looking rollup config where we do things like replacements, depending if we're in browser or node, or even just for the WASI transformation, we replace this because it's an ES6 thing that we don't want to output for our users. We also have a TypeScript config that we use the overarching project TypeScript config, but depending on the project, we sometimes do different little things for each library. And then we input all of our CommonJS and globals and built-ins and stuff like that. We had Json support. And sometimes we copy files from our node modules into the actual assets. That way they can be easily retrieved from our users without having to go dig inside of different node modules for different assets and things. We format. So every library that supports node I guess every library supports at least an immediately invoked function expression, which means like, hey, I want to use this on the browser without any bundler at all. I just want to use it. And then also ESM, so that way their bundler can tree shake and stuff. We don't output anything other than ESM and IFI. And then if they support Node as well, we also export a CommonJS module. So that way we support both browser and Node and multiple different options depending on what they want to do with the bundle itself. So yeah, everything can work almost everywhere is what I'm trying to say, I guess. The one thing I will bring up is Cyrus, or I guess us in general, are upset about the build times. Right now, they're about 30 seconds to build all 4 packages. The reason why it is like that is because we have to build WASI and WasumFS first. Then we can kick off the next builds. So these two slow down this build. But also, because we're using TypeScript, a lot of the TypeScript plugins for Rollup, whether it be either through the TypeScript plugin built for Rollup or Babel's version of TypeScript, are both slower. And it's like a known bug on TypeScript right now. So that would slows down our bundle a lot. And I guess not moving away from TypeScript, but maybe finding a way to use a TypeScript compiler first, and then taking that output and then throwing it into Rollup might be the best option. But then we'll have to introduce something like Gulp, which is just another future idea I've been having. But yeah, so I guess build times here could be better. But other than that, Rollup makes it really flexible, and that's about it. I think that's a good overview of Wasmer.js. Do you have any questions, anybody? Do you think?
Can you do a demo of basically like how like someone that like haven't like seen the repo yet, like how they can start kind of like just seeing the development mode and just playing with it?
Yeah, sure. So let me stop sharing my screen. That way I can show my entire screen, not just the application window. New share. Yeah. Share my entire screen. Cool. Can you see my entire screen now?
Yes. Yeah.
All right, cool. So let me close this. Boop, boop, boop. So this is me messing around with Xterm.js. So what you'll do here is I'll go to, I'm going to Wasmer.js. What you would normally do is npm install. This step usually takes a while because it's installing everything from everywhere. And then, actually, I could just show you the instructions. What am I doing? I don't have to remember this by heart. Oh no, my laptop's gonna die. All right, we'll do this. So pretty much all the instructions are here. For the quick start, you go here and do npm install. And what this does, we have a post install script, which will run them after npm install no matter what, and it runs through Bootstrap, which then goes into your individual packages and installs those and gets those ready as well. Which is exactly what it did. As you can see here, npx Lerner Bootstrap. And then from next, we would go ahead and do npm run build. The reason why we have to do it here is because, what was I going to say? Oh, it's because we do a lot of copying, like I said, in Rollup, to copy some of our assets or some of our node module assets into our assets folder that is then used within the library. And what npm build is going to do is build the 3 JavaScript libraries. It won't build the Rust crate quite yet. The reason for that is because the Rust crate does a bunch of weird stuff. And for the most part, like now that the Rust crate works, you probably don't need to update it that often, unless you find like a major bug. And even then, that has its own, like, we have other things for watching that as well. But for our main build, we also don't want to slow things down. So we figured, we'll just build these 3. And yep, and this is why I said it takes a little bit. Like you can see here, this one took about like 14 seconds, but it runs in parallel with WasumFS, which is nice. And I don't need this to take as long. And then it's still building. My laptop's probably gonna die. Yeah, see 17%, it's doing all the building. Oh, there we go. But so yeah, I guess it took about a minute. So it takes a minute to build. It kind of sucks, but it's because we're building dependent packages. So that's the reason for it. And then this is for the general Wasm shell example, and that is what we saw. Where would we see it? We saw right here. This is the Wasm Terminal Wasm shell example. If you run npm run dev, but I'll go ahead and kick off some watchers. The watchers don't build when you first press dev. That way you don't have to like wait for it to finish building so that you can then see the actual website. So because it's serving now, the actual example, it gives you the Zeit serve npm package that we're using. So you go to examples and then Wasm shell, and then here we are. And we have an example of how everything works. And there you go.
Nice.
Is that a good overview?
Yes. Yeah, I think that's
cool.
Perfect. Cool.
Yeah, if I may do, a lot of things are documented really well. Even like when it comes down to deploying these packages, I think there is an npm run deploy that I wrote. Yep, here it is. And for people who are trying to contribute, they can't deploy because they don't have npm credentials. But it's as simple as just running npm run deploy, and then if you ever need to build this and publish it, you totally can with that command, and you go from there.
Perfect.
Yeah, I don't have the keys to the castle. It's all documented. And I guess the last thing to go over is WebAssembly.sh. This is literally just the exact same just in a PWA form. The reason why the way we achieved that was using Preact CLI. It's all Preact based. Preact is a super small React. React is about 30 kilobytes. Preact is 10 times smaller than that. It's about 3. And we're using their release candidate for version 3. The reason why we're using the release candidate is because I worked with a lot of the Preact members back on AMP, and it was something they were working on for a long time. They're on RC5, and they were like, I even pinged one of my old friends that's on the Preact team, the person that actually makes Preact CLI, and he's like, yeah, we're gonna, oops, I clicked a link on accident. He was like, oh yeah, we're gonna release the full thing pretty soon. So I didn't see a point in still using version 2 when number 3 is gonna come out anyways. So we're kind of ahead of the curve there. And we're not using a rerouter or anything. We're just using Preact, so it's about 3 kilobytes, and I guess we get this fetch polyfill. What this does is it does a lot of things like, you can read through the feature list, but it does service workers, so offline support. That's one thing that I got to fit in, I'm super stoked about, is that if you run cow say hello while you're on the internet, like even on your phone, and you go on an airplane, you can still use the Wasm shell because it'll have all the assets pre-cached, even the transformers and everything like that. And as long as you ran the command while you're online, it will still be in your IndexedDB cache. So you can use the Wasm shell offline, totally. So that's pretty cool. And then what else? It does a lot of we have support for less than Sass. We don't use it, but we have it there. And it doesn't add anything to our bundle size or make the experience any different for developers, really. And yeah, it has plugins and things. And I don't think we're not doing too much custom. Let me go off and show that too. cd WebAssembly.sh. Did I show the code last time? No, I'll just go in here because I went over here. I see what's going on. So yeah, looking at the package JSON here, it is pretty much just the default generated Preact CLI thing, like Preact build just does Preact build, things like that. Some of the only funny thing we're doing is that we're copying over some of the assets from Wasum Terminal into our Preact assets directory, because Preact, it looks in the assets directory to do all the service worker magic. So it can automatically go ahead and do things like pre-cache some of our CSS files and Wasm files and things like that. The only thing we're doing custom outside of Preact CLI expects is we have our own service worker, which is literally copied from the Preact service worker. But I added this one line because I was having trouble with the Wasm files and the worker file. So I added this custom 4 lines of code, and then it got everything working offline, which is really nice. Or everything working offline outside of the normal web dev workflow of what Preact expects, because Preact is like create React app, or Preact CLI is. Other than that, it's not doing anything super crazy. It's just literally using the Wasm Terminal API. The only thing that I guess would be notable is we have our own callback command called Wapum, which is just a light version of Wapum, so you can do things like install local Wasm modules and install from Wapum at certain versions and stuff. And that's just running GraphQL calls. And Cyrus made this, so Cyrus knows more about it than I do. But yeah, and that's about it. It also has a help command, and then we have other little callback commands for help and about. But for the most part, it's just using Wasum Terminal and the whole Wasmer-JS stack, as I've been calling it on Twitter and things,
Nice.
to run commands. Yeah. So yeah, that's about it. That's what I've been working on. And yeah.
Can you do a quick demo as well, like of WebAssembly.sh? Kind of like this.
Yeah, sure. So WebAssembly.sh, what you would normally see, it showed it in this GIF maybe, but normally what will happen when you visit the website, you'll get a little badge right here that says, hey, you should install this PWA. And when you do, you click open, and then you get a much clearer looking window. It's completely black. I think it looks really good. I'm stoked on it. And then you get the general prompt right here, and it's like, hey, look, using WebAssembly.sh, it tells you what version you're on, and the version is broken, but it tells you what version you're on. And then it has some quick start commands and stuff like that. And if you were on a browser that didn't support, oh man, I lost it. I can't believe I did that. There it is. It also supports links. That's one thing I added as well. So if you click a link, it'll open up in a new tab, which is really handy for things like the About page. You don't have to copy and paste. You just click the link and it works. What was I going to say? I was going to say something, but yeah, Wasm.sh is cool. Let's just do cal say hi. I can even show off like the offline. Well, no, I can't go offline because I'm doing a video call. Since it's a window, you can technically do this. So I did cal say hi. I did that. So if I go to network and then I go offline, hopefully this works. No internet. But if I was offline on here, it should work. But oh, there it goes. See, I don't know why I chose to do it late, but now if we do cal say hi, even though we're offline, it'll still go ahead and run cal say. And if you try, let's say, wow, what's a good example? Like quick.js, it's going to fail because it couldn't go online. So it is offline, and installed commands still work, which is super cool.
So all the commands that are in Wapom list are the ones that you can use offline, right?
Yeah. I just made it back online, but yeah, I would still be able to use Rust Python and things because I've already installed it.
Nice.
So yeah. And is there anything else I should say about Wasm.sh?
No, I think that's a very good overview.
Cool. Yeah, and I'm really excited for people to use it. Also, you can drag and drop, like I said. We'll probably make that, once we get the file system as well, you'll be able to drag and drop anything. So if you wanted to run Clang in Wasm.sh, for example, or sketchyclang.io or something has their own Clang compiler, you can totally like drag and drop it, and then you can use that without having to actually use it on your local machine, which is really cool. As you can see, there's a little bit of bugs that like showed up on the wrong place, but we're working through them. People seemed happy about it, so we're doing good. But yeah, I think that's good. Anything else you want me to say? Go over?
No, I think that was perfect.
All right, cool. But yeah, I guess TLDR too on the Wasm.sh. This is a PWA, and all we did to do that was just use Preact CLI on top of our current Wasmer.js stack.
Mm-hmm. Okay.
And custom.
Yes.
But yeah, I think that's all I got to say.
Perfect.